The bulkhead, which is subject to both soil and water pressure, is 2,400 pounds and is pinned to the ground at point A. Assuming the system is in equilibrium, determine all support reactions. In order to solve a problem like this, step 1, you need to draw free body diagram. So first we need to draw free body diagram and show all acting and reacting forces on this free body diagram. So the forces that we have, starting from the top, we have this support reaction, which is F. We don't know the magnitude of it. Then we have the weight of the system, this bulkhead, which is 2,400. And we have a pressure that soil raises, and it's distributed in a triangular shape. Therefore, it's going to be area underneath this triangle, and it will act 1/3 from the base of triangle, which is 7 feet, because the triangle is 20 here and 1 feet in here, 21 feet. Therefore, it's going to be 7 feet from down. And also we have a pressure from the water, and that's going to be act again 1/3 from the base of this triangle, and it's going to be 4 feet because the height is 12. 12 divided to 3 is 4 feet. And their magnitude, as I mentioned, is going to be equal to the area underneath this triangle. So it's going to be 150 times the area. The height is 21 divided to 2, and it's equal to 1575 pounds. And the second force from water is going to be equal to 50 times the height is 12 divided to 2, and it's equal to 300 pounds. Then you need to show the distances that we have. So the distance from here to here, we said that is 4 feet. For this one, it's going to be 7 feet, and for this one, it's already given, it's 20 feet. Then you have to show the support reactions because it's pinned. Therefore, we have two support reactions. One is Fy and the other one is Fx. Now you can write the equations and equilibrium and find and all these forces that we don't know the magnitude of them. Because we have an F in here that we don't know. First, I start with taking moment about point A. So sigma m about A is 0. And the reason I'm taking moment about A is because then I can eliminate Fx and Fy, and I can find F, because these two forces don't have any moment about the point that they are acting. And assuming that this is my positive direction, say F times the distance is 20 feet. Then the second force that has moment is this one, 1575, and it's acting in the opposite direction. Therefore, it's going to be negative 1575 times the distance is 7 feet. And the third force is this 300, and 300 is acting in the positive direction that I have assumed, and it's going to be 300 times the distance is 4 feet. Then this 2400, it doesn't have any moment because it passes through this point. Therefore, its moment is 0, and we can close the equation. It's equal to 0. You can solve this. It's going to be F is equal to 1 over 20 times 1575 times 7 is 11,025. Because you're moving to the other side of equal, it becomes positive, and this will become negative. Minus 1200, and it's equal to 491.3 pounds. So we calculated this F. Now you can write sigma Fx is 0 and sigma Fy is 0 and find the other two unknown forces. Don't forget, the goal in this chapter is finding the unknown forces, and the unknown forces are usually the forces that act on supports or support reactions. So sigma Fx is 0. We have the first force, that is this one we calculated, 491.3 plus 300 comes from here, and minus 1575 and plus Fx is 0. From here Fx is going to be equal 783.7 pounds. We calculated this, and if you write sigma Fy is 0, it's going to be very simple because we have just one force in vertical direction and it's 2400. That means that Fy is just 2400 pounds. So you calculated all three support reactions that you needed.